My name is Paul Cassak. I am a professor in the Department of Physics and Astronomy at West Virginia University. My research is theoretical and computational plasma physics. So I do work on processes that happen in especially space plasma systems like the sun and magnetic reconnection, Earth's magnetic field, and the region in between of interplanetary space. Plasmas are very different than the gases that we're used to in our day-to-day lives. Like the gas in the room that you're in is typically in what's called local thermodynamic equilibrium. And what that means is at every point in space, you can measure a temperature, and that temperature is well defined. In plasmas, though, it doesn't always work that way, and often it's not in local thermodynamic equilibrium. And what that means is that you can't necessarily define a temperature everywhere in space. This makes studying them very challenging. The standard approaches that people use don't work very well, and so we can't use the tools that we're used to using. Magnetic reconnection is a process that happens in plasmas where you have a magnetic field that changes direction over a region of space, and the magnetic field lines come together, and you can sort of think of it as though they effectively break. The energy in the magnetic field gets converted into these fast jets of plasma shooting out from where reconnection happens. So it's the energy release mechanism in solar flares. The changes to Earth's magnetic fields out in space affect us here on Earth. They can cause jolts of electricity in power lines that can trip transformers and cause power outages. It can cause damage to satellites out in space, so we can't use them for communication. In fusion, people use magnetic fields to confine plasmas to try to get the particles to fuse so we can extract that energy. When magnetic reconnection happens, it sort of breaks those magnetic field lines and allows the plasma to leave, and so it's not confined anymore, and so it stops undergoing fusion. Measuring magnetic reconnection is really challenging because there's a lot of aspects to it. One of the workhorse ways to study plasma physics is with computer simulations. We often use supercomputers. The equations of plasma physics are pretty well known, but they're really hard to solve. And the reason they're really hard to solve is because plasmas, at least where magnetic reconnection happens, you have what's called a nonlinear system. The standard description of a plasma is a fluid description. You describe the plasma as bulk properties of what a large number of particles are doing in a small space and how that changes in time. And what kinetic theory does, how that differs from the fluid picture, is that you're really tracking what the particles are doing more individually. And so it gives you a lot more information about what the plasma is doing. Kinetic theory simulations tend to be larger and more computationally expensive, but they retain the information that you lose when you use fluid theory. Scientists solve problems that both are of scientific interest, but they often are very important to our day-to-day lives. What I would recommend for students or people interested in science is, most importantly, just be curious and don't get daunted by how much there is out there. And it's a slow process to learn science, and it's okay. So just keep at it.